Hello. Hello, hello. Hello, can you hear me? Maybe it's good now. Let's check. Hello. Yeah, now it's good. Hello, can you hear me? Now it's good. Now it's good. So now let's jump right into our one of our last courses here. Because in this, we're taking the career track, which is called AI Associate AI Engineer for Developers. And here we have done many courses already, 6 as far as I counted, plus 3 projects. And now we're going to go to the three last courses, which are probably more advanced than the previous ones. And now we're gonna do building applications with Pinecone. That is basically, Pinecone is a vector database. Before we were having ChromaDB, which was our local database. Probably we can also have the hosted version somewhere at some provider. So yeah, I think we're good. Now I will try to cover as much as possible today, and then we will either do a second streaming in this channel, and just in case, this is gonna be probably my last stream on this channel, because I have another channel that is called Luis Enrique Builds, in which I am gonna stream right there, because this channel is mainly for music. I just didn't want to spend time until YouTube approves my streaming in the other channel, so I just started streaming here. But as far as like the approval has been confirmed, I'm just waiting for they to activate my account. So I'm gonna do streaming there for the coding, programming, engineering and stuff. So this is probably gonna be the last stream on this channel, and the next time is gonna be in the other channel, and I'll just share it in the description.
Hi, welcome to this course on Pinecone. Pinecone is a leading fully managed vector database solution for building and scaling generative AI applications. Like other vector databases, it uses embeddings to store and retrieve data based on their semantic similarity, which is often integrated into chatbots, search engines, recommendation engines, or other AI systems. In this course, we'll learn to ingest vectors into Pinecone indexes, and retrieve and query these vectors to create systems very similar to what is used in common AI applications. Let's dive in. Indexes are one of the core components of the Pinecone infrastructure. They are used to store vectors and serve queries and other manipulations over the vectors it contains. We can think of indexes like drawers in a filing cabinet. Each drawer contains folders of information, and indexes contain records. Each vector is contained in a record, and the record also stores additional metadata that can be used in querying. It's also possible to create multiple indexes to house different datasets, like the different drawers in the cabinet. There are 2 types of indexes in Pinecone: serverless and pod-based indexes. In pod-based indexes, we choose one or more pre-configured units of hardware called pods, in which we create the index. Depending on the pod type chosen, we get different amounts of storage, query latency, and query throughput. Serverless indexes don't require managing resources. Instead, they scale automatically depending on usage. Serverless indexes run as a managed service on a cloud platform, like AWS, and the vectors are stored in blob storage on that platform. In many cases, serverless indexes result in lower costs than pod-based indexes, which is leading many organizations to switch to serverless. In this course, we'll be using serverless indexes, as these are accessible with Pinecone's free starter plan. However, much of what we'll learn will also apply to pod-based indexes. To work with Pinecone in Python,
And this is really important, because we need to we need to make sure that that we use the free
complete the
plan so
exercises
far.
in this course, you'll need to create a Pinecone account and API key. To create a Pinecone account, navigate to pinecone.io and sign up for a starter account. Once registration is complete, head to the API keys page and copy your API key. This can be used throughout the course in the exercises and won't be stored anywhere. The first step to working with Pinecone in Python is to import the Pinecone API client. This client is used to configure the environment to work with the API, including specifying the API key. We also import serverless spec, which is used for creating a serverless index. To create the index, we call the create index method on the client, and specify what we should name the index. When creating an index, we also need to specify the dimensionality of the vectors it will store. This index can store vectors represented by 1,536 numbers. Finally, we indicate we want to create a serverless index by passing the serverless spec function to the spec argument. Inside, we specify the cloud provider and region we wish to store the indexes in. We can verify our index was created by calling the list indexes method on the client. There we have it. Time to create your very first Pinecone index.
It's awesome. So Creating a Pinecone client. To the code you write a Python code to interact with Pinecone via Pinecone from client. As you need to create your own Pinecone API key. Pinecone cases using this corrector will not be stored in any way. So basically here is asking me to put my API key. It's gonna not be stored. God knows. But okay, so I'm gonna put just my face because now I'm going to create my Pinecone account. Just give me a couple of minutes because this is private. I'm also gonna ask Cloud to make sure that the folder that I create inside this course is called applications with Pinecone. Then I'm gonna ask Cloud to do what we did in the same way that we stored in the our OpenAI API key. We need to do the same, but for the Pinecone API key. Okay. So I'm going to create an index. Oh no, I need to go to the API keys. Okay. And then it says create an API key. This API key is gonna be learning. Pinecone. So now I'm going to cuatro. All right. Now in here I should do import Pinecone. And I'm gonna ask Cloud that inside of this applications with Pinecone on this folder in the same way that we did to import the client. Now we do something similar but with Pinecone. Can you please create a file there and follow the same rules as not login and stuff like that. Here in the VS Code, I think I had I should exclude the files and the search from the everything that it's in the amp. And I'm gonna ask, let me know if you have any questions. And give me a second because I'm trying to make sure that everything is properly set up so none of the keys are being visualized. I think for my next streamings, I'm also gonna try to figure out that when I'm here in this black screen, I should have some sort of like background, maybe a video game in the background, so you guys like follow up what's going on in here. Meanwhile, I'm programmer. To the example, yes, updated. I also need to do many things like masking uh, masking my terminal, masking my. Okay, so here it is. .m load.m. You get the Pinecone API key. It's not set. Mm, yes. Okay, I connected. I mean, I cannot show you what is the key right now. It's so annoying because I cannot share my screen right now because it's asking me to put a API key in every single file of here, and it's not right. Another, okay, I'm gonna have to check to cloud in data account, so that is a way I can set an environment variable, so I don't need to write the key on the Pinecone key on the screen. Okay, so let me check if in the previous exercise I do Pinecone, and if here I do Pinecone, and then I do, sorry, API key is equals to there it's okay, let's try this. Okay, yeah, so if I put the okay, give me 1 second because I'm testing some things here, so I make sure that I don't show my key. That dimension is 256. This is gonna be a problem. In the first exercise, it wasn't. It wasn't asking my API key, but now it is asking. Okay, guys, I don't really know how to proceed with this because can you research online? Because now I'm on an exercise and it is not The virus is hitting wherever you're going. Yeah, I'm asking now. I'm on an exercise. I mean, I'm streaming. I don't want to show my key. Okay, guys, I have bad news. So it doesn't allow it, and that's pretty bad. So what we are going to do right now is possibly I think that the easiest solution here will be to just show you my Visual Studio. Yeah. Um, yeah, let's make a copy here. Visual Studio. Let's move this here. This full screen display for the moment. We're just gonna hide it just to not make this mistake that, oh, maybe maybe we by mistake click here and it appears my key, so I don't want to do that. Okay, so we have the no screen, the tutorial of Visual Studio, in which I'm just going to show this. I need to remove this. And I need to do window capture, which is going to be Visual Studio, which is gonna be here. And it's going to be here, okay? Then I'm gonna be copying and pasting each one of the exercises into here. And oh, what happened? Okay, I'm there. So I'm just gonna do all of it here, including running the commands from git bash. I'm gonna just run it here. Clear, clear, clear. Okay, it works. So here I'm gonna run cloud. Here I'm gonna go the commands of the exercises. I'm not gonna show you nothing from the screen here. So then I'm gonna copy the exercises. Okay. So okay, now we're gonna go with the first one, which is gonna be your first. This is gonna be the first exercise. This is gonna be so the AI systems with no applications with Python. And here I'm gonna touch creating Pinecone index .py. Oh, it doesn't allow touch? Okay. So I'm just gonna do here good here, and then I'm just gonna do this. I just need to import this, and I'm gonna do from Pinecone client import Pinecone, because here I already defined how to get the import PC, sorry. So here I already have the Pinecone client, so I don't need to do anything there. Here I'm gonna do clear. Here I have cloud. So in this file, if I run Python, I forgot to put the index there. Here, one no model name Pinecone, so I'm gonna do pip install as user Pinecone. I'm just gonna check in my YouTube if everything is like correct. I'm just gonna check in my YouTube if everything is like correct. I'm just gonna check in my YouTube if everything is like correct. Oh, I see that I need to reduce my, so you can see my YouTube if everything is like correct. Okay, now it's good. Now it's good. Now it's full screen. Now I can see my Visual Studio Code. Now all of my secrets are hidden, and now you can see that I can run. I just installed I just installed the Pinecone. So now I'm gonna run this. And here I should have successfully created an index. So if I go to my I'm gonna I'm gonna create a new this is gonna be, yeah. So now here I'm gonna see the results that I got from the Pinecone in the Pinecone database vector of the web view of the provider. Here you can see in my it's copying this. Okay, so 1 second, let me fix this. So here is gonna be from my Visual Studio Code. Then in here I'm going to here I'm gonna put the my first, yeah, the Pinecone view. In this case, this I'm going to remove. So okay, here I'm gonna create a new one, which is gonna be a window capture. This is gonna be Visual Studio. Visual Studio is already in use. Huh. Okay, so I'm gonna put this into Visual Studio. In here, we're going to do window capture, and this is gonna be Firefox public. And here I'm gonna put this from Pinecone. So give me 1 second. In one side we have the Pinecone, in the other side we have the Visual Studio, and here we have just me. And we're gonna jump from all of this tree. Here I'm gonna show the results. Here I'm gonna show the Visual Studio, and here I'm gonna show just myself, probably with some background at some point. So as you may see here, because I run the code here to create the Pinecone, now I see that there's my first index there. So far it's good. So far it's good. We created now, because of the fact that you cannot see my key, I can peacefully just paste my key. Give me 1 second just to okay, it's good. I can see my two databases. I can okay. Now if I do this and then for some reason I show, yeah, so you cannot see my key, so that's good. So you can see that I created here the index. Here you can see my code, and now we're good. Now I'm gonna write on my own the the I'm gonna run on my own the exercise data camp. Okay, I want to show you this, but so in order for me to do this, then I will need to Firefox public. How to do this? How to show you this lecture? How to show this lecture without compromising my keys? Maybe let's make a duplicate here. Data camp. So we just need to remember that each time that we Firefox public, we remove this. Here we do the data camp. And in here, yeah, we show this. Yeah, and now did you see that there? Then we can close this. Now you can see it here. Now I'm gonna check that in. Oh, I see that I need to reduce. I need to watch the lectures. Now I'm gonna check that in. Oh, I see that I need to reduce. Yeah, I don't know. Yeah, oh, it's all good. It's all good. So now, okay, now it's time to watch this lecture. So let's just watch it.
Welcome back. After creating the Pinecone Python client and creating a serverless index with our desired specifications, we need to actually connect to the index to begin ingesting vectors and querying them. We can do this with the client's index method, passing it the index to connect to. We assign the resulting object to index, which has its own Python methods for manipulating the vectors it contains. Note that if we try to connect to an index that...
Just in case, so far as I'm making the analog between a regular database and a vector database, I think the data camp, the index is something like a table.
Manipulating the vectors it contains. Note that if we try to connect to an index that hasn't been created, we get a 404 error message that the index wasn't found. One of the most common Pinecone index methods is describe index stats, which returns information about the number of vectors in the index, the proportion of the index that is full, the fullness, and the dimensionality of the index, which should correspond to what was set when the index was created. There's also an empty dictionary to hold namespaces. Let's talk about those. Namespaces are essentially containers for partitioning indexes into smaller units. This could be to keep distinct datasets or data versions separate, or perhaps to partition groups in the parent dataset. Queries and other manipulations are then limited to that namespace. For now, we'll focus on working within a single namespace. But later in the course, we'll discuss distributing vectors and querying across multiple namespaces. Organizations also play a key role in managing indexes. They provide control over access and billing to different Pinecone projects. Pinecone projects can contain many indexes, so the Pinecone ecosystem consists of a hierarchy of organizations at the top, down to projects, indexes, namespaces, and individual records. There are two types of organization roles: organization owner and organization user. Organization owners have permission across the entire organization. This includes managing billing, users, and all projects. Organization users have restricted organization level permissions. Organization owners invite them to the organization and assign them to specific projects, of which they become project owners. Finally, if our data is no longer of use, or the index no longer suits our use case, we may want to delete it. We can do this with the delete index method. When we do this, we'll see the index disappear in the list indexes output. It's important to note that deleting an index also deletes all of the records it contains, so delete with caution. Time to try these new methods out.
Okay, guys, so we streamed for 40 minutes. Let's take a small break. Now, as you see, we need to now hide this. And here you have Visual Studio, this one here, and this one. Oh, no screen, the Visual Studio, and here. Now, okay, let's just finish this exercise, okay? So now I'm gonna show you the Visual Studio. Now we need to create a second file, which is called connecting to index. And well, I already have here the PC defined, this import from here. I don't need the serverless spec. And now what I'm going to do is I need to connect to that index. So this is already created. In my case, I need to connect to my first index pc dot connect, and I should say something like this. So yeah, I have this here. And in my Visual Studio, I need just in case, because in the first file we already created my first index. Then here we are kind of already connected, and here we're going to describe the stats. So if I run Python and this too, I'll get the stacks of this first index, which is going to be like an empty, but at least it's going to describe the number of dimensions that we defined earlier. And that's pretty much. Now I'm going to run also this into data camp, just to finish this part. Yes, perfect. So this is our 10-day streak. We can also delete the index. Okay, let's do this in another file. And this also is a delete index. So in this case, we're gonna do basically the same. It's here, pc that in here we do my first index. So basically what I need to do here is this. I'm gonna delete my index. Here should be other quotes. And I'm gonna first run my code into I didn't put under quotes this. Give me 1 second because it's running. Okay, so now you're seeing my Visual Studio, and now here I'm gonna reload the page because I just removed this index. So I'm gonna run 1, 2, and 3, so you can see how I create the index, how I list the properties, and how I remove the index. So in my first file, first I'm going to Python 1. Here I'm creating the index. Did good, no errors. Now if I go to the public and I reload the page, you will see that it's here. And now if I run the last one, which is the 3, which is deleting the index, and then if it runs correctly, then you will see that there is no that index anymore here. Okay, good. I deleted the index. So if I go, so if you see here, I just run the delete index, it's deleted. And if I go here, you will see that there is no this index anymore. So they were good. Now let's go into this data camp because I have some answers, so questions to answer. So PyCon ecosystem. The PyCon ecosystem consists of several different components, and you have learned our organization projects and names and records. How they are arranged in hierarchy. Okay, in hierarchy, first is the organization, then the organization has many projects, the projects has many indexes, and then an index can have many namespaces, and namespaces can have records. That's good. Vector ingestion. Okay, guys, so let's take a small break, and we're gonna come back like in an hour. So maybe I'll go to gym and have some rest.